everybody, it's Mrs. Pound, and we're moving on into a new unit and a new chapter. So, chapter 3.1 is about crust movement. The first section we're going to talk about, section 311, is on continental drift. So, our objectives today are to explore the theory of isostasy, explain the theory of continental drift, and relate how scientific progress depends on the work of past scientists. So one thing I'm going to say is that all of these topics we're going to talk about, uh, they were developed over time with input from many different scientists. I'm not going to necessarily get into the history of it all and tell you what scientists did what. If you're interested in that, you can look at that in the section of your book. Your book goes into that in pretty good detail. So this idea of isostasy, this is the equilibrium in the Earth's crust maintained by a flow of rock material in the asthenosphere. I have a picture of an iceberg in the background because basically what isostasy, the big idea in isostasy is that the continents are in the crust are like icebergs on the ocean. You could think of the ocean as the asthenosphere, and the continents are in the crust are floating on top. And like icebergs, they can move. And like icebergs, most of the crust is sunk underneath. You can't see it all. It's not all necessarily on top, okay, due to various reasons that we'll get into. This was this was the theory of Clarence Dutton. He came up with this first, and it was not accepted. But now it's accepted as more evidence has been gathered. And the idea is, like an iceberg, denser crust sinks lower in the asthenosphere. So surprisingly enough, actually the oceanic crust is denser. It actually will sink lower than the continental crust because of its density difference. However, mountains sink lower than flatlands because they have more mass. So we have this sinking going on due to density and mass. There's also the theory of continental drift. And this is the theory that the continents can move apart from each other and have done so in the past. And the evidence for this, both direct and indirect, are the shape of the continents. It was noticed early on that the continents look kind of like a jigsaw puzzle. For example, if you take South America here, it looks like it really fits nicely next to Africa over here. And if you took North America, you could wrap it around this way. There are also glacier features that were discovered near the equator. Now, near the equator is nice and warm, so how would glacial features be near the equator unless perhaps they moved from a northern or southern position towards the equator, a more polar position? Also, there are coal deposits in the polar regions. Coal is from dead plants and animals, okay? And especially tropical type where you have a lot of vegetation. And so in order to have coal in the polar regions, it seems that it would have to move there from an area that had more vegetation. Also, there were dinosaur fossils that were found on Africa and in South America that seemed to match up in similar layers of sediment, and when you took the continents and you put them together back like a jigsaw puzzle, they matched up in those layers. There are also satellite images, and this is a direct form of observation. Satellites have actually recorded movement of the continents. Very slow. We're talking centimeters per year, but slow enough or fast enough that a satellite can see this movement. There are also changes in the magnetic poles that have been recorded. we're going to talk about the mid-oceanic ridges. On the sides of the ridges where new material is laid, where new rock is laid, they have seen these shifts in the magnetic poles, which is evidenced by these lines here that are moving away, that would be away from a ridge. And they're a lot like the rings in a tree as far as being laid down. So explanations for the movements of the continents. How in the world do these big things move? Now, young Earth scientists say that it is the decaying electrical current in the metallic core which provides energy for continental movement. And they would also say that catastrophes would cause rapid movement of these continents. Okay. Old Earth scientists would say that due to the principle of uniformitarianism, that things are happening gradually and it's the same processes over time, that the Earth's rotation and convection form a self-sustaining dynamo that developed over millions of years and drives continental drift. So we had talked about this before, that in the mantle, rock rises as it becomes less dense. As it cools, it falls and creates convection currents. And so old Earth scientists would cite those convection currents as one of the reasons that the continents are moving. Now, this whole study of the movement of the crust is called tectonics. This is the study of the movement and changes in the rocks that make up the Earth's crust. And so this is our current theory about movement of the crust. Is called plate tectonics, and plate tectonics states that the continents are on what we call different plates that are in motion and are moving and actually recycle the rock on Earth. It's part of the rock cycle. And we're going to get more into the details of plate tectonics in the next video. So our objectives were to explore the theory of isostasy, explain the theory of continental drift, and relate how scientific progress depends on the work of past scientists. So, and like I said, if you want more information about the history of those scientists, go ahead and look at your book, but I didn't go into detail on that. Don't forget your 5 questions, and we'll be back with more on plate boundaries and plate tectonics in the next video.